let's say the sequence is this. Okay? Let me take off a few here for set. All right? Okay, so I'm just going to draw the ends of the strands because that's what's important. Okay? And so if we draw the other strand here, and you should be able to do this mentally, right? You know what the other strand is because you see this here. And if we think about last week, if I were to point to this end, which end is that? Is that a 5' end or a 3' end? 5 prime, okay? So if this is 5', what end is over here? 3 prime. Okay. And we do the same thing for this. This would be what? 3 prime, 5 prime. Okay. So let's say this is the sequence we want to replicate. You want to design primers. Now, for purposes of simplifying this, we'll make them 7 nucleotides long, right? In reality, that actually won't work. You have to be 20, but we'll make them 7 just to illustrate the principle. Okay. And so, and you want to make copies of this sequence, all right? Now, one of the things you want to think about as well is this primer is going to be used by DNA polymerase. Okay, so you have a primer, you have DNA polymerase that will start at that primer and then start to make the DNA, right, in one direction or another. Okay. Question is, which direction does it go? So let's say, let me just write another sequence. Let's say you have this sequence. Which way will the DNA polymerase go? Will it go to the left or to the right? It actually goes from left to right. Okay, so if this was the other strand, DNA polymerase would go here and then go this way. Okay? All right, so people see that?
Yes.
Okay, so let's say we start it with, we have these sequences here, because all you really need are the ends. So if you wanted to have a primer, and you wanted DNA polymerase to replicate, make it direct to go this way, right? What would that primer be? Okay, what would that primer be? So you have basically 4 choices, because again, it's the ends of the sequence, okay, that will define the DNA molecule to be produced. So here are the ends. So you have 4 choices. So which one is it going to be? You want to make a copy. You want to make this strand. So which? Yes.
The CGA brand. That would be your primer.
Okay, so that would be
Bottom.
the bottom one. All right. So let's take a look at that one. So let's say you use that one. Okay. So just to remind ourselves, this end would be what? 5 prime. 3 prime. Okay. Okay. So now, where is DNA polymerase going to bind? On the left side or the right side?
Oh.
No, it's going to bind. Actually, going to bind here, right? Because it binds on the 3 prime end. Okay. Right. So, which way is DNA polymerase going to go? To the left or right? To the left, right? Because the primer is here. You have to imagine the other strand here. So, right. So DNA polymerase is going to go this way. Okay. All right. And so you're going to make a copy of which strand? Top strand or the bottom strand? The bottom, right? Because you're basically making a copy of the bottom. You're actually going to duplicate that bottom strand. Because here, this is the top strand. This is the bottom strand. Because your primer is on the bottom. Your primer is the same as the bottom strand. Okay? Right? So you actually solved a different question, which is how to make the bottom strand. You use this sequence. Okay? So this is actually one of the primers you would use. Okay? Question is, what would you use to make the top strand? We still have one more strand to go.
The 5' ACT, CC.
Yeah, it's actually this one. Okay? Alright, do people see that? Because imagine you need polymerase binding here, okay? And it's going to go, because it goes from 5' to 3', that's the basic rule. And so it's going to go from 5' to 3', which is the direction of the top strand, and it's going to go like this to make the top, basically make a copy of that top strand, because it has the bottom strand as a template. All right? Okay, see that? So one thing you have to picture in mind, because I'm just drawing one strand, but you actually have millions and millions of these strands floating around in your mixture, okay? And likewise, you have millions and millions of these DNA primers, right? And so each of those primers is going to pair up like this with the bottom strands that are in that mixture, okay? And what, as a consequence, when you add the Taq polymerase, it's going to be making the top strand of each of those DNA molecules, right? And you just denature these again in the next round of PCR to make even more. Okay? And likewise, along with these strands, you have the bottom strands floating in there as well, okay? All right, and in this case you have the other primer, which is going to bind to, all right, that strand like that and go the other direction, okay? All right, so you'll be able to make those molecules that way, okay?
Can you talk about how
At the
the
same
reverse
time?
primer is special?
Which primer?
The reverse one, you can just submit it like that to the. first
Yeah,
one.
so the other point is, if you were to write this, you always write a sequence from like this, 5' to 3'. So if you were to actually write this bottom primer, how would you write it out?
GCT.
You have to go from 5' to 3', so it'd actually be GCTAAGC. Okay? All right, so all right, people see that this sequence is the same as that one? Yeah, I just flipped it around, but that's actually if you were to actually write this out, okay? Like if you were to order this, which I'm going to do today because I want to do this experiment, so I'm going to order some primers. All right? All right, you have to do it that way, okay? Any questions about this?